Around the globe, data is everywhere, growing exponentially.
Data powers entire businesses.
Fueling industries with insights, knowledge, and opportunities.
We've been on a mission to help organizations mobilize their data with the Snowflake Data Cloud.
Now you can break down silos of data, uniting teams across your business.
You can share data with suppliers and partners to drive decisions.
And tap third-party data instantly.
To gain new insights and a competitive edge.
When you have the full story, you can serve your customers in entirely new ways.
The Data Cloud is redefining your industry.
Helping realize your company's vision.
Empowering you to build the future.
By bringing data
together
now.
Good morning, I'm Remo Biagioni, and I'm going to spend the next 20 minutes or so talking through OAG's migration into the cloud. In particular, the things I'm going to talk about is what we do as a business and actually how that's driven the cloud migration and why that migration is so important to us. I'll talk a little bit about the process that we went through to select Snowflake and what we wanted to achieve out of this migration. Then I'm going to talk through some of the good stuff that's happened with the migration. Data sharing and data science have been two things that have been absolutely transformed by our use of the cloud and Snowflake. And then I'll talk a bit about our developer experience, which has had both of its ups and its downs, what's good and what's bad. And I do want to spend some time talking about performance. Snowflake's a fantastically scalable platform, but it's something that's got to be used right, and understanding performance is probably the biggest learning that we've had over the last year of using the platform. And finally, I'm going to talk about some of the really cool stuff that you get in Snowflake, or at least the cool stuff that I enjoy playing with. And there'll be a bit of time at the end for Q&A. So OAG is an old company. We've always been forward-looking to the point that we actually started our business before even Orville took his first flight. And we primarily sell aviation schedules and status information. We computerized very rapidly. We got our first computers in the 1960s. By the 1990s, we were dishing out schedules on CD-ROMs and then moved rapidly into the internet. We've got various bits of tech across the business. As you can imagine, as an old company, it's grown and it's accumulated. We're primarily run off DB2, but also we've got SQL Server, a little bit of Oracle. If you look underneath some of the covers, you'll find some COBOL, and we have a MySQL database as well, just supporting our status products. One of the reasons why we wanted to move to the cloud was to start consolidating this technology. What OAG does is it takes in data from various sources around the world, from airlines, airports, governments. ADS-B is a way of actually tracking aircraft when they're in the air, and they send regular geographic pings, and various third-party data sets, things like fleet information, so specialist companies that gather information about which carriers own which aircraft, how many of them there are, and how they're configured, and who owns what, as well as amenities data. One of the oddest data items that I think that we track is the size of windows on aircraft. Apparently that's very popular amongst certain classes of travelers. We're a data aggregator, so we bring that data in, we quality check it, we clean it, we load it into our systems, then we aggregate it and we sell it on to various businesses. We sell it back to some airlines. It's very useful for competitor tracking, to airports. The travel tech sector is one that's really grown up in the last 10 or 20 years. Companies like Skyscanner and multiple others that take in data from all sorts of places so that they can produce really new and innovative ways of looking at the data, as well as providing data to governments, finance houses, commodities brokers. OAG Metis is our new platform that we've been building over the last year. And the idea of Metis is that we get a single version of the truth that we can supply to customers in different formats. So really the key thing here is that instead of being bound to the old ways of transferring data, that you can access it through API, through our direct channel that I'll talk about a lot more later, our analytics platform, and also alerts, so that customers can subscribe just to the changes that they want to see. A little bit about me. My specialism is data. I've been working with data for quite a while. I joined OAG just before the global pandemic hit, which was a fantastic time to join the aviation industry. My specialism over the last few years has been really around data quality and master data management, and it was those two disciplines that I really wanted to bring into OAG as we started to build out our new platform. So our goal, it was really simply to get that single version of the truth at the center of everything that we do. Because each of our products is currently built separately on different technology stacks, it may start with the same data, but there are different implementations of the calculations. So it is possible to look at 3 different products that we supply and find a different number of seats on a particular aircraft. And in some cases, you can even find different departure times. We wanted to move away from that so that we have that single version of the truth that the products then pick up on and supply to customers, so that whichever of our products you look at, you always get the same answer. Faster development, speed to market is core to my heart as an IT developer. Until we actually get something in front of customers, we don't get feedback, we don't know it's adding value, we don't know we're heading in the right direction. Any technology that helps us get things faster to customers has got to be worthwhile implementing. Measurable data quality. We pride ourselves on having the best data quality in the industry, but we have no real way of measuring that because our data sets are disparate, they're spread over multiple systems. Gathering all of that together and really understanding what our data quality is difficult. One of the things that we wanted to achieve was to be able to put in place metrics that we can track, we can measure, and that we can improve, so that we've got real targeted improvements that we can build on and that we know our quality is getting better. Part of that is actually giving people across the business access to the data. With our existing databases, which are really heavily used constantly in production, it's very difficult to give people access. With Snowflake, that's one of the things that we've been able to do, because fundamentally, the more people that look at the data, the more problems they'll find with the data, the more we can fix, so that we fix the problems before our customers will see them. And that's how we get a virtuous cycle going of improving our data quality. And finally, being able to do this in near real time. Many of our customers are just demanding faster and faster access to the data, especially over the last year, where there's been an awful lot of churn in the aviation industry, with flights being put on and flights being cancelled at short notice. So why did we go down the Snowflake path? We started looking in October 2019 and ran a few workshops over the next 4 months to narrow down a list of vendors that would be worthwhile exploring further. And then in February 2020, we ran a series of proofs of concepts, one with Snowflake, one with Databricks, one with Azure Synapse. We also looked at using Azure Web Functions and SQL Server in the cloud. Snowflake came out head and shoulders above the rest. What we got from Snowflake was, first, fantastic support. We knew that we were going to need this as we moved forward because we didn't have any experience migrating to the cloud. So that level of support that we got from Snowflake and helping us build things, especially through the POC and afterwards, has just been really good. The go-to-market aspects of it were important. One of the things that Snowflake wanted from us was aviation data and be able to put that into the data marketplace. So we've had a lot of joint marketing efforts with Snowflake, and they've helped us actually reach customers that we wouldn't have been able to reach, and vice versa. I mean, fundamentally, having something in the cloud that's a platform as a service that we're not maintaining. As a data professional, one of the things I've been trying to do is to migrate away from relying on DBAs constantly. That PaaS system really brings that to us. What we've built is an architecture that puts Snowflake at the center, and Snowflake delivers that single version of the truth. So we bring our schedules data and we bring our status data in, load it into the Snowflake platform, aggregate it, transform it, and serve it out through various different channels. And one of the things this platform has brought is that ability to have multiple access channels. So our customers are no longer bound to a choice between FTP or SFTP. They can come in through a modern API, through our Analyzer, which is our analytical platform built on top of the star schema, which uses the data that's underlying there in Snowflake, and even the legacy traditional aviation standard formats such as SIM can all be brought out and exposed off the same data source. The alerts product is something that's really quite new. We're actually publishing changes of schedules and status to event hubs, and even starting to publish changes of data quality metrics through event hubs that our customers can subscribe to, so they can see what's happening on our systems and also with their schedules and any flights that they want to track. This is incredibly useful for companies that, for travel agents that do business travel, where if a flight gets cancelled, they want to be able to rebook their business traveller as soon as possible, causing the minimum disruption. Data sharing. Last September, we started a market experiment where we took a number of our schedules and we loaded them into Snowflake and then exposed them through data sharing. Data sharing is a fantastic piece of technology. It's implemented by Snowflake's separation of compute and storage. And that simply means that the storage can be accessed by different Snowflake accounts in a safe, secure, and controlled manner. If you told me 2 years ago that I would be letting customers have SQL access directly to my database, I'd have probably walked out of the conversation. But Snowflake allows us to do that securely. So because the underlying storage sits just in blobs on Azure, we can allow other Snowflake customers to point at that blob storage and they see our tables as we change them, but they're not using any of our compute. Their compute is completely separate, so it has absolutely no impact on what we're doing. And any contention is managed through a metadata layer. One way that we see that implemented is through the Snowflake Marketplace. So the Snowflake Marketplace is literally a marketplace of different data sources. Early on in the pandemic, we found a source of data that allowed us to track the COVID spread throughout the world, which we were able to use in our internal reporting. And similarly, now you can find aviation schedules in the marketplace. So we publish a schedule to the marketplace once every 3 months. So it's not as up to date as the data that we charge for, but it still brings a lot of value. And anybody with a Snowflake account can just point their Snowflake account at the marketplace and get those aviation schedules. And similarly, our customers, who are also Snowflake customers, can point their Snowflake accounts at our data and see those schedules in real time as we're actually updating them. Reader accounts allow us to do this with customers who aren't Snowflake customers. So a reader account is simply a cut down Snowflake account that we manage on behalf of the customer. So we control how much they can spend on processing. We can see what data that they've got and how they're using that data. And it's a really great way of letting customers access the data. And our customers love this. Those that have migrated to reader accounts just find it really easy because our data is exposed to them just through SQL. So it's a language that everybody understands, everybody can access the data, and they can see how the tables are structured. And it takes away an awful lot of pain in file transfers, checking that the file has been transferred correctly, checking the format's right. The format that they get with this is simply a database table, so everything is strongly typed. Around the world, you obviously get internet delays if you try to access data in one place, or say you try to access data from West Europe and you happen to be in Australia, there's going to be a delay as the laws of physics kick in. With Snowflake, we can actually replicate our data around the world into each of their major data centers, and then customers who are also in that data center can access the data in the same data center. And replication was one of the easiest things to set up. It's as simple as creating a new Snowflake account, which is all done through the interface, going onto the new account, saying, I'd like this database, going onto the source database and saying, allow that account to replicate, and then it happens. And it happens quickly. So we have a 1.5 terabyte table that gets replicated in something like half an hour, and updates to that table take less than a few minutes to replicate around the world. And in this way, we've been able to share our data with customers across the world. So we've got customers using this in India, in Japan, quite a few in America, and one in New Zealand. And it enables us to give that direct access to customers without worrying about transferring the data. OAG Data Science. So in June 2019, OAG put its toe in the water with data science. We employed a few data scientists and asked them to start looking at our data to see what they could find with it, and they really struggled. Our legacy systems were not designed to give easy access to the data. For example, DB2 is highly structured with tables that are minutely modeled and not very easily available. Similarly, even our MySQL databases were very difficult to access because you start taking processor capacity away from it, and these databases are constantly under use. So the guys were able to copy only small amounts of data from those systems to their laptops and start exploring with it, which obviously means that data science has a very, very slow start. When we implemented Snowflake, that changed. One of the first things that we did was start copying data onto Snowflake without doing any transformations, just to make the copy quick and then give the data scientists access to it. And they were able to explore the data and start building machine learning models. We had multiple proofs of concepts running internally, and from those we selected OAG seats. So one of the traditional problems with aviation is working out how many seats there are on an aircraft. For those of you who have flown, you may be surprised at that, but it's actually quite difficult knowing which particular aircraft a carrier is going to use on which particular journey, and each aircraft can have different configurations of seats. And those of you who have seen movable curtains will know that that configuration can even change on the same aircraft between journeys. So OAG seats is our first machine learning model that we've actually productionized and made available to customers and have sold a number of times since April this year. The data scientists have moved on to build multiple models since then that we've exposed to customers through various customer trials. And actually, this is where data sharing and data science come in really strongly together, because we've created the models and we've created the data, and then we can use data sharing to share the results with our customers rapidly and give them a trial access to something that we might choose to develop in the future. One of these models is our green flights, which tracks how sustainable a particular flight is, the emissions that come out of the aircraft through its various stages of the journey, and we provide that information to clients so that they can start to build their own models and start to model how environmentally friendly their flights are. The developer experience of Snowflake. This has been quite nuanced. Some of our developers really like Snowflake, some don't. One of the things that people like is the SQL is standard. The SQL is just straight out of the box. Anybody who's worked with Oracle or on Microsoft SQL Server or even MySQL can just jump straight into Snowflake and just use standard SQL. There are some extensions to it, and one of my favorites and one of the ones that sounds most science fiction is time travel. So you can select data at any point in a table. So if a table has changed, so you've inserted more data to it or you've updated rows in the table, you can actually go back and see what the table looked like a few hours ago or a few days ago. And this is, again, because Snowflake have separated their storage from compute, and it just works. And that separation enables storing and using very large volumes of data. So the Snowflake virtual warehouses only actually bring in the data from a table that they need to use, and they track that through metadata, and everything is stored in micropartitions. And this means that you can have very large tables, but actually still compute on them very, very quickly. And the scalability is immense. There's a range of virtual warehouses that you can use, ranging from extra small through to triple extra large, with different numbers of processors that you can allocate to them. The majority of our compute actually happens on extra small warehouses with 1 or 2 clusters, and very occasionally we let the data scientists play with a large warehouse. But what we could do with that increase in power through to the triple extra large blows my mind. One of the big things about it is that data is accessible to everyone. So we give anybody who wants it, and we encourage people to have access to our production data sources. And we can do this safely because the production jobs are running on warehouses that nobody else can access. And then we set up different warehouses for different parts of the company so that we can track what they're doing and how they're working with it, so that we can improve the experience for them, as well as control costs. And just giving data available to everyone means that more people look at the data, more people understand the data. We even have salespeople building Tableau reports directly from Snowflake, and other salespeople teaching themselves SQL. It's been a complete transformation for us as a company just to give that data accessibility. And part of that is it's always been a struggle to give developers access to production data. With Snowflake, we share the data from the production environment to the development environment, and then the developers can read from that data, they can modify that data, they can do what they want to the data without affecting the production system, and it just works. And fundamentally, we don't need DBAs. So if we want to restore a backup, that can all be done by the developers. If we want to take a backup, we can take zero-copy clones. That's just a bit of SQL. We can use time travel to look to see what happened. Snowflake takes care of its own indexing and data storage and partitioning. So there's very, very little maintenance that needs to be done on Snowflake. One of the things in particular our Microsoft developers have struggled with is that a lack of standard tooling. They're very used to an environment where everything just comes out of the box. Snowflake is a database. There isn't a preferred client. There isn't a preferred migration tool. There are tools out there that you can use, but you've got to go out and choose your own. And there are some standard ones that people suggest, such as Airflow, but it's very much the developer's choice, or very much an architectural choice of which tools we want to use for what. Security is one of my favorite features in Snowflake. It is complete role-based security, which means that we can give people who do similar jobs exactly the same access and control it through their roles. The flip side of that is that it can be rather confusing. And certainly some of our developers get confused about it because you can give access to particular columns on particular tables. So one person might be able to see one thing, but won't understand why somebody else can't see exactly the same thing. Snowflake is a columnar database, and this is very different to the way that it works to a row-based database. When you start working with it, it just feels the same, but its performance characteristics are different. And the way that you store data is different, and then the way that you can access data and looking for point queries versus aggregate queries, it's something to be aware of, and there are strengths to both. And once you get into the columnar side of it and understand how you might want to structure your queries, it becomes very, very powerful. Similarly with micropartitions. So Snowflake splits a table into micropartitions. Each of those partitions has a fixed size and has a cluster key. And the cluster key depends how you actually search across the partitions. So performance, especially on large tables, is very dependent on that cluster key that you've chosen. Because if you've chosen a key that's good and works for the way that you want to query the data, it means much less data actually gets transferred into Snowflake. But understanding this and working through it is actually quite hard, and most of our developers have been on quite a steep learning curve with this. And the flip side of that is that when you get it wrong, yes, you can allocate more power, but power comes with costs. So that we pay for processing time, and we pay more for a very large warehouse than we do for a very small warehouse. So when we make that compromise between, yeah, we need more power to crunch through this table, that increases our costs. Something that puzzled many of our developers to start is that cost is based on warehouse uptime, not usage. And the two things sound kind of similar. And personally, I like the way that Snowflake has implemented this. I think it comes with some advantages. But from the developer point of view, they want to know that the query that they put in is going to run, and they just get charged for that query. But actually what happens in the background is that the warehouse is either up or it's down, and we get charged for the amount of time that it's up, and it won't switch itself off after a query has run. Now, you can tell a warehouse to suspend itself, and at that point you stop getting charged, but there are advantages to leaving one up and running. For example, caching, which is something that I'm going to come to shortly. So some more on performance. The way that Snowflake runs a query is that you send a query to Snowflake, it'll be run against a particular warehouse. That warehouse might be up or it might be down. If the warehouse is up, the query runs quite a bit faster. If not, there is a bit of initialization that the warehouse has to go through. And all of these things really depend on the size of the query that you're running. So if you're running a query that's going to take half an hour, if the warehouse takes 500 milliseconds to initialize, you don't really care. If you're expecting a response back within a couple of hundred milliseconds, then that startup time has an impact. When the warehouse starts, it has a completely empty cache. So the warehouse basically consists of a processor and local storage. It will also take the query and will attempt to parallelize it. So on a single cluster warehouse, you can have up to 8 parallel processors running at the same time. That's configurable. You can have slightly more, but generally larger queries will not run in parallel as well as multiple smaller ones. But there is a bit of work there that Snowflake has to do, which is work out how to parallelize the query and then allocate it to various CPUs. The next thing it's got to do is get the data. So all of the data sits on blob storage or S3 if you're using an AWS version of Snowflake. That data needs to be transferred into the warehouse. And this is where the cluster key comes in, because it will attempt to transfer the minimum number of micropartitions that it needs to run the query. The local disks that the warehouse uses are all SSDs, so they're really quite fast, whereas blob storage is really quite slow. Pruning reduces the number of micropartitions that are actually needed, and that's again is where the cluster key comes in. So if you have a very large table, your performance is really dependent on what cluster key that you've chosen. Snowflake, when you create a table, Snowflake will automatically create a cluster key, but it's something that you can change and something that you can tune. Fundamentally, the difference between a small warehouse and a large warehouse is more CPU, more cache, more RAM, more SSD, just more of everything. Obviously, the more data you've got in the cache, the faster the query will run, the more you've got in the SSD, the less you have to do. Where you see queries really slow down, it's when they have to start changing that storage from SSD back to block and swapping things in and out, and that can take time. And that's really when you need to be using a larger warehouse. One of the oddities is that a small query can run faster on a small warehouse than it would on a large warehouse. And this comes back down to parallelization, that a small query just can't be parallelized. So the work that Snowflake has to go through to actually allocate a query to particular clusters doesn't need to be done on a small query, but it still takes time to be done. I know this is something that Snowflake are working on to speed up, but it is quite something just to be a little bit aware of. And one of the good things about Snowflake is the performance characteristics it gives you. You can see my profile overview on the slide of how it breaks down the processing time of a query, and you can see how much time it's spent getting data from the remote disks onto the local disks, which are the SSDs, and actually just crunching through it. With the pruning element at the bottom of there is really quite powerful. You can see on this particular table that was being queried, there's 1,800 different micropartitions, and we only needed to use 300 of those to actually get the results of this query. The smaller the number of partitions that you need to bring in, the faster the query will run. One of the things we have found with this is that the Snowflake support has been excellent. Every time we get puzzled by this, and we've had Snowflake consultants actually come in and help us tune our queries and help us tune our structures, that Snowflake have just been there to hold us by the hand, make it run faster, explain how it works, and when they don't understand how something works, they take it back to their development team, and every query has an ID that they can just go back, give it to their development teams, and they can look in to see exactly how that query was optimized, how it ran, what it did, and then they can come back to us with information on how to make it better. The sunny days, the cool stuff. This is some of the stuff that I really, really quite like about Snowflake. This is a bit of a personal list, and if you spoke to somebody else from our organization, you may well get a different list. Top of my list is integration with our supplier storage. So we have a couple of suppliers that use AWS to crunch through their data. And what they can do is that they just put something into S3 And our Snowflake instance, which actually sits on Azure, it connects to AWS, and we read their file as if it sat within our own environment. So one of those suppliers updates that file every week, and that's just invisible to us. We just see the changes as they happen, as if it was on in our own environment. If I talk about time travel and undrop, I'd like you to understand that this is purely a metaphorical story, and it's not something that really happened, especially if my boss is listening. Say, for example, you're working with a developer in Boston who's about to retire, and he's talking you through some of the tables that he's created. And he's created a table that is a copy of another table and probably should be tidied up, and you spend 5 minutes talking this through with him, and you decide, yep, we're just going to drop that table from our production system because it's not needed. So you type drop table, you check with the developer to make sure that this table really isn't needed. You press return and the table's dropped. Then the developer says, sorry, that was the wrong table. The Snowflake command undrop is a wonderful thing in that circumstance. I mentioned earlier being able to share data from production to the development environments. That's just wherever I've worked. It's the thing that developers have always wanted, access to the production environment so that they can see what happens to the data. With Snowflake, we just share the data with them and they can play with it to their heart's content. Zero copy clones. We can copy data, and some of our data, as I mentioned, is terabytes big without actually copying it. So Snowflake just uses a metadata operation, and the only thing that's recorded is changes that you make to that data, so that you're not creating multiple terabytes just for the sake of it. And it makes it really easy to work with an awful lot of data. Global replication, I mentioned when we talked about data sharing. I've worked on projects before where to replicate databases took weeks and weeks, specifically around certain geographies, where just having to put the on-premises database in, establish fast enough connections between the databases, it made a major project. With Snowflake, we're talking about an operation that takes an hour from thinking about doing it to having replication set up and running. Query isolation. The fact that we can have as many warehouses on Snowflake as we want means that we can isolate our production queries from the queries that our data quality team are running to the queries that I run that perhaps, according to some of my developers, aren't particularly efficient. And those queries can run without affecting anything in production or affecting anybody else's queries. The data marketplace, I think, is one of the biggest innovations because it gives us a new channel to market that just didn't exist a few years ago, allows us to find other data sources, and has already started bringing us new customers. And finally, no DBAs. Snowflake just looks after itself. We don't need to be worried about how the data's clustered, how it's stored, partition schemas. All of that just happens underneath the hood and just works. Thank you for watching. I look forward to taking any questions.